I'm going to work out several sample stoichiometry problems with you. These can be found on page 320 of your textbook. It's in the chapter review, and these are from section 2. I'll also do a couple of them from chapter 11, but that will be in a separate video. So you'll need to get your book out. You will need a periodic table, and I will also use this stoichiometry map as a reference. I'll go back and forth to it, so you might also want to print that out or at least have it pulled up on your desktop so you can get to it quickly. You don't have to have it, but it might be helpful. All right, so stoichiometry, we have to have a balanced chemical reaction. So if they don't give us a balanced reaction, that's the first thing we're going to have to do. So starting with number 5. Hydrogen and oxygen react under a specific set of conditions to produce water according to the following. A. How many moles of hydrogen would be required to produce 5 moles of water? So if we look at the number that they've given us in 5A, 5.0, it's in units of moles, so that's what we're giving. And then we have to say, well, what are we looking for? Well, we're looking for moles of hydrogen. So if we go back and we look at our road map here, we're starting with moles and we want to end with moles. So if we look on the very first page, this one says moles to moles. So we're going to take moles of substance A and put it on top of the first box. We're going to look at our chemical reaction and see how many moles of A we have, and then put that on bottom. And on top of that, we're going to put moles of B. So whatever our second substance is. You look down here where it has the asterisk, it says if we have moles B over moles A, this means the molar ratio from the balanced equation are our coefficients. So let's say we make water A and hydrogen B. We have 5.0 moles of water. So that's moles of A, and that's given to us in the problem. That's what we always start with. And then it says down in this bottom box, we need to have moles of A. This comes from our molar ratio from our balanced chemical equation. So H2O, how many moles of H2O do we have? We look at this coefficient of 2. Oops. So that coefficient of 2 now goes in the bottom down here. So 2 moles of H2O. And then on top of that, it said moles of B. Go in the box above it. Well, what are we trying to find? And the question is, how many moles of hydrogen? So hydrogen would be our B. So if we go back to that chemical reaction and look to see how many moles of hydrogen we have, if we look, 2. So we put 2 moles of H2. Right. So going back and looking at our chemical reaction, we can say for every 2 moles of H2, we can make 2 moles of H2O. So 2 moles of H2 over 2 moles of H2. This right here is now called a molar ratio. And we will have to use a molar ratio just about every single problem we have to do in stoichiometry. So if I talk about a molar ratio, this comes from my balanced chemical equation. I'm going to erase this now so I can write my answer down. All right. So what we do mathematically, we can now get our calculator. We started with moles of water, and in this last box we have moles of hydrogen. So now we know to stop. We don't have to go any further. So we multiply the numbers across the top, so 5.0 times 2, and then we divide by the numbers on bottom. So what we can say, 5 times 2 is 10, and then the only number that we have on bottom is 2. And so now our answer is 5.0 moles of H2. Make sure that you are writing down the formulas that you're using, because if you'll notice, we started out with H2, which is water, and then we ended up with just H2, or hydrogen. So we have to write down which compound we are referring to. So 5.0 moles of H2, that's our final answer. So 5A is done. 5B, how many moles of oxygen would be required? Okay, so we still have 5 moles of H2O. So how much O2 could we get? So if we have we have 5 moles of H2O. How many moles of oxygen gas would we get out of this? So now, we go back to our little road map here. We're still doing moles to moles, so we still have to use that very first one where it says moles of A. A would be H2O, and B would be whatever we're trying to find. So that would be our oxygen gas. So if we go back to our balanced equation, we see for every 2 moles of H2O, we have only 1 mole of O2. So if there's not a number in front of there, if there's not a coefficient, it's understood to be 1. So we're going to put 2 moles of H2O on the bottom, and it said 1 mole of O2 on the top. Another way that we can kind of keep this straight, whatever units and compound you have in this box has to be diagonal from it. So if I have moles of H2O in this top one, I have to have moles of H2O down here. I can't put moles of O2 down here and expect it to cancel out with moles of H2O. They have to have the same units and the same compound. So again, we multiply across the top and we get an answer, which is just 5 moles. We multiply across the bottom, we just get 2. And then we put this in our calculator, or maybe you can do this wonderful math in your head, and we get 2.5 moles of O2 gas. All right, so now that is our answer for B. We're just going from moles to moles. These are the easiest ones to do. They're the shortest ones. And problem number 6. 4.5 moles of ethane undergo combustion according to the unbalanced equation. How many moles of oxygen are required? Very important here. It says unbalanced equation, so the first thing we have to do is balance it. We have C2H6 plus O2 yields CO2 plus H2O. If I put a 2 there and a 3 here, it's not going to work. So we have to double our numbers now. We've got to put a 2 there, a 4 here, and 6 there. That gives me 7 there. All right, so now I have a balanced equation. They've told me I have 4.5 moles of ethane, and then I'm trying to find moles of oxygen. So again, we're just going from moles to moles. We go back to that mole road map. It's this very first one, moles of A to moles of B. A is whatever's given to us. B is what we're trying to find. So 4.50 moles of ethane is given. We go back to our balanced equation. If I have moles of ethane here, I have to have moles of ethane down in the bottom, the diagonal box. So where am I going to find that number? From my balanced equation. So if I look, I have 2 moles of ethane there. So I'm going to write 2 moles of C2H6. And then I'm trying to find moles of oxygen. So here's my moles of oxygen. I have 7. So I put that on top. All right, so now you're going to multiply across the top and get an answer. Multiply across the bottom and get an answer. Put that in your calculator, and you should get 15.8 moles of O2. Right. Part B asks how many moles of each product are formed. So we know how many moles of oxygen, that's one of our reactants. And now what's now products? So we really have to have 2 answers here. We need to know how much CO2 we have and how much H2O are we going to have. So I'm going to erase part A so I have room to do B. Okay. So we know we have 4.5 moles, sorry, of ethane. And we are going to change this to moles of product. Which one do we start with? It doesn't matter. We're just going to do CO2. So if I have moles of ethane in this box, I have to have moles of ethane in this box. And if I look at my balanced chemical equation, I have 2. And now I need products, so I'm going to start with CO2. I have 4 of them. I'm just going to plug this in. It's 4 moles of CO2. So I have moles of product. I can stop there. I'm going to multiply across the top and get an answer. Multiply across the bottom and get an answer. And divide the 2. So here you should get 9 moles of CO2. And so now we have to do the exact same thing for water. So we're still going to start with the number that they've given us in the problem. That's our 4.50 moles C2H6. I have moles of C2H6 here, so I have to have moles of C2H6 here. If I look back at my chemical reaction, I have 2 moles C2H6. And now my other product is water. I have 6 moles of H2O, so I'm going to write this in here. And now I can multiply across the top and get an answer, multiply across the bottom and get an answer, and divide those 2 values. And you should get 13.5 moles of H2O. All right, our next problem. Number 7. Sodium chloride is produced from its elements through a synthesis reaction. What mass of each reactant would be required to produce 25 moles of sodium chloride? So this is taking us back a little bit. They don't give us a reaction, so we're going to have to write one out. So sodium chloride, its formula is NaCl. So it's produced, that's our product. It comes from its elements and its reactant. So that would be sodium plus chlorine. And don't forget, chlorine is a diatomic, so it has to have Cl2. Now to balance that reaction, put a 2 here and a 2 here. So now it says what mass of each reactant would be required to produce 25 moles of sodium chloride. So they gave us 25 moles. and we're trying to find grams of each reactant. So when we see the word mass, its units are always going to be grams. All right, so we're going to start with what they give us. All right, so we have moles of NaCl, and we're trying to find grams of a reactant. So we're going from moles to grams. So that's this one. We have to have moles of A, moles of A, moles of B, 1 mole of B, and molar mass of B. So if we go back to chapter 3, we learned molar mass. It says down here, add up the masses from the periodic table for each element in your compound. All right. So, I have moles of NaCl here. In this box, I have to have moles of NaCl here, and it's going to come from my balanced chemical reaction. So right here, I'm putting in 2 moles NaCl. All right, well, what am I trying to find? It wants to know how many grams of each reactant, so I'm just going to start with my first one, and we're going to say Na. So if I look at that, I know I have 2 moles of Na. In the last problem, this is where we stopped, because it asked for moles. But my question asked for grams, so I have to go another step. And if we go back to that roadmap, after I get my moles here, now I have to do molar mass. So now I need my periodic table. So I'm going to look on my periodic table and look up the mass of Na. It's 22.99 grams. And it says that number needs to go on the top. And then we know that all the masses on the periodic table are grams per mole. So if I have 22.99 grams of sodium, that's in 1 mole of sodium. All right, so now the question asks, what is the mass of my reactant? Grams tells me mass. Na is my reactant. So I can quit drawing boxes and get out my calculator. So you're going to multiply all the numbers across the top and get an answer. You're going to multiply all the numbers across the bottom and get an answer, and divide those two values. So you should get 575 grams of sodium if we round that to 3 significant figures. All right, so now we have to do another one. It said each reactant. So now we get to do this all over again for chlorine. So we're still going to start with the number that they've given us in the problem, and that's 25 moles of sodium chloride. I still have to do a mole ratio. So if I go back to my equation, for every 2 moles of NaCl, I produce 1 mole of chlorine gas. This is this box. I have 2 moles of NaCl, and I only have 1 mole of Cl2. All right, the question asks for the mass of our reactant, and right now we have moles, so we need to do one more box, changing our moles to grams. And if we go back to that sheet, it tells us we've got moles, so we need to do one more step. We need molar mass. So if we look on the periodic table and we look up the mass of chlorine, it is 35.45, but we have 2 of them. So we need to multiply that by 2. We get 70.90 grams of chlorine gas, and that's in 1 mole of chlorine. So now we have grams, which tells us mass. We have Cl2, which is our reactant. So we can stop and get our calculator. We multiply across the top and get an answer. We multiply across the bottom and get an answer. And we divide the two values. And we should get 886 grams of chlorine if we round to 3 significant figures. Right, I'm going to stop the recording here and pick up with the next video.